going to be talking about combinations and how to go about solving them, so we're just going to dive right in. So first thing is that when we talk about combinations, order does not matter when we're arranging things in that set. So for instance, if you look right here, you have clearly 3 different permutations. They all look very distinctly different. However, they're all the same combination because no matter what, I'm always talking about 3 blue circles and 4 red circles. So they represent all the same combination. So our notation for combinations versus permutations is actually quite similar. So it's NCR as opposed to NPR. And what we essentially need to do is we need to divide out all the permutations that are essentially the exact same in terms of what they contain. So that's why we take NPR and we divide by R factorial, where R is how many things we're selecting. So by extension, what this means is when we have some set, so let's say I take these 7 circles here and say, hey, I've got 7 circles, and I'm going to combine all 7. Well, when we're talking about rearranging the entire set, there's only one way to arrange that entire set. Even though we are moving things around within it, there's only one combination of all things within that set, and that is those things. So, yeah, so basically what ends up happening is when we're talking about combinations, we're always going to have substantially less or substantially fewer than when we compare them to permutations of the exact same number. And in terms of what we do, we're just going to take our permutation formula and divide it by R factorial. And so you can simplify and get something like that out to make our math a little bit easier. So let's just do a few examples together. So a smoothie stand offers 15 different types of fruit and allows customers to pick 4 to put into the actual smoothie itself. So how many different smoothies are there? Well, because order doesn't matter, like if you've got, your smoothie, it's supposed to be a blender, but if once you're putting that fruit in there, it doesn't really matter what order you put the fruit in. When you blend it all, it looks the same. So the example that I would have used in class is that a strawberry, that's a long word, a strawberry banana smoothie is the exact same thing as a banana strawberry smoothie. Okay, you can't tell which fruit went in first and after it's all blended up. So basically, we've got 15 fruit options, and we're going to choose 4 of them. So when we expand out, you would get 15 factorial over 4 factorial onto 15 minus 4 factorial. And of course, I'd simplify a little bit, and I'd say 15 factorial onto 4 or divided by 4 factorial, 4 factorial, excuse me. 15 minus 4 is 11 factorial. And I can simplify this a little bit. So I could say 15 times 14 times 13 times 12 times 11. And once I hit that 11, I can just tack on the factorial symbol because now it'll match up always with that 11 factorial. Still have that 4 factorial. So I'm going to divide that. And I can simplify this even more because 4 factorial is the same as 6. Sorry, no, it's not the same as 24. That was a close one. So if it's 24, then I can start dividing. For instance, the 12 and the 24 can be halved. So I'll get 15 times 14 times 13 over 2. And then I could, what did I say, so it was 24, yeah, so it would be 1 over 2. And then I could divide it by the 14, which would give me 7. So let me write this out as I'm saying things. So what I'm saying is this 12 and this 24 here, I can view that as a fraction unto itself and just write it as a half. So I can view this as 15 times 14 times 13 all over 2, i.e. 1 over 2. And then the 14 and the 2 can divide into each other. So I'll get 15 times 7 times 13 as a final answer. Let's keep going here. School is picking 5 students from its AP program to send to a conference. If there are 90 students in the AP program, how many different group options are there to send to the conference? In this case, clearly, there's no order of it doesn't matter whether I say Jack, Mary, and John go or John, Mary, and Jack. They all are the same combination because there's no assigned specific roles. So I'll just say I've got 90 students and I'm going to choose 5 of them. And I would simplify that and say 90 factorial over 5 factorial onto 85 factorial. And that 85 is, I'm doing 90 minus 5. And I could simplify that again to 90 times 89 times 88 times 87 times 86. And then once I get to 85, they'd cancel all over 5 factorial. And then I could expand that out and keep canceling down, but that's not really the goal of this. I'm just, as long as we know how to set this up, we're good. A lottery allows people to pick numbers between 0 and 1, so between 1 and 50, and that would, of course, be inclusive. If that's not, on an assessment, I'll always try to indicate whether it's inclusive or not, but this is a fair assumption to make. that would be inclusive. And if 6 numbers are drawn, how many different combinations of numbers are there? So from 0 to 50, or excuse me, from 1 to 50 means we have 50 numbers, and we are going to choose 6 of them. Okay. Now, some of you might be wondering, like, doesn't order matter in that case? And the answer is no, because if you can imagine, like, you've got someone who's picking, balls out from a lottery box here, and the balls all are numbered between 1 and 50. It doesn't matter whether they pick the 1 first or the 50 first or whatever it is, or the 7. Like, at the end, they're going to have the 6 different numbers in front of them, and they're all going to be the same combination. It doesn't matter whether 167 or 761. It's the same combination. So that's why we have to use a combination. And if I wanted to actually put in the formula, I would write 50 factorial over 6 factorial over 50 minus 6 will give me 44 factorial, which is still a fairly big number. I believe it's over 15 million different ways that we can combine those 6 numbers. So when we're talking about combinations, basically we have like an increasing level of difficulty here. So I'm using the same example each time, just kind of hit it home. But the first level is we've got just no real restrictions. Okay, so in this instance, we've got a coach who's picking members for a basketball team. 20 students try out, and they need to pick 12. How many different ways are there for them to form the team? Because order isn't indicated here, it's not asking how many ways are them to pick a center or forward or whatever. Like it's just the 12 basketball players. We're not talking about specific positions here. So I'll just go 20, choose 12, and that'll tell me how many different ways to form that team are. And the second one here, if you look, we've got some cases because they can pick between 10 and 12 students. So what that means is we have a situation where they go 20, choose 10, or they could pick 11, so that'll be 20, choose 11, or they could pick 12, 20, choose 12. Okay, because it's, I'm saying or each time because they could do the 10 or 11 or 12. I'm going to link that together with addition because in each of those cases that satisfies the condition. So I'm going to add all those options together, and that'll tell me how many different combinations there are. And finally, we've got some more nuance here. So a coach is picking members from a basketball team, for a basketball team. 20 students try out, but we now know some things about the subpopulations in there, the subsets. So I know there's 12 grade 9s and 8 grade 10s. So how many ways are for them to form a team if they need to pick at least 5 grade 10s to form a team of 12? So because we're talking about like the subsets within the population, this is going to trigger cases, and at the same time, I'm going to use my fundamental counting theorem. So I'm going to say case 1 is they're going to pick the 5 grade 10s. So they pick 5 grade 10s. 5 grade 10s. So I have to think about how many grade 10s I have. So I have 8 grade 10s. So it'll be 8 choose 5 times 12 choose, how many do they have? 12 choose 7. Okay. So to be clear, this 8 and that 12, they form together to make our entire population there. Okay. 8 and 12, number of students who tried out. Number of students tried out. The 5 and the 7 are how many we're picking for the team. So that right there, this is the team. Okay, and you'll notice 5 plus 7 is our, that's how many students we can take for our team, how many players we can take for our team. Some of you might be wondering, why did we multiply there? I thought with cases we added. Well, this is still just one case. So I'm not going to start adding until I get to another case. And to be clear, I'm linking these two statements here with the word and. I'm picking grade 10s and grade 9s for my team. Okay, I am linking them with and. I'm not saying grade 10s or grade 9s. I'm saying, hey, 5 grade 10s and 7 grade 9s. So that's one option. Case 2, I've got 6 grade 10s. Okay, because it says at least 5 grade 10s. So 6 grade 10s also satisfies that, right? Because, 6 is definitely at least 5. So what I'm going to do is the exact same setup. I'm going to say 8 choose 6 times 12 choose 6. And again, you're going to notice some common things here. The 8 and the 12 still add up to 20. And the 6 and the 6 both add up to 12. Okay, so I'm still talking about forming a team of 12 from an overall population of 20. It just so happens I know more about my subsets within that population, and that's what I'm using to calculate. Case 3 is going to be 7 grade 10s And that's going to be, I don't know what color I'm using, red here, so I'll keep using red. So I'm going to do 8, choose 7, times 12, choose 5. And again, just to highlight this, I still have my population of 20. Oh, I kind of went a different color. That's never good to mix up my colors. Let's try that again here. Erase. Oh, I somehow selected a, turn that off. Someone selected a little arrow there. I don't need that arrow there. Erase. Boom, boom. Let's try this again. What is it? 8 and 12, and I was using blue for this. So 8 and the 12 are the subsets, and then the 7 and the 5 are how many are trying out for the team. And then finally, 8, choose 8, times 12, choose 4. And this is case 4, where we have 8 grade 10. So this is where we actually pick all the grade 10s that tried out. They make the team. Okay. And once again, I'll highlight, just at home, 8 and 12, and you've got the 8 and the 4, both adding up to 20 and 12 respectively. In all these cases, I would figure out that number and I would add together. I would sum them. Okay. Now, a different way we can approach this is we can, so this is kind of approaching it positively. We're going to say the 6th grade 10s, or 7th grade 10s, or 8th grade 10s, or 9th grade 10s, or however many grade 10s we have, we're approaching it positively. We could do the complement to this, though. And we could look at how many ways are there to form the team with no grade 10s. So no grade 10s, or not no grade 10s, I should say 4 or fewer grade 10s. So 4 or fewer. And see if that's the other way you can view this, right? We can kind of view it the opposite. And so what I need to do here is I need to say, okay, what's the total number of combinations? And then I'm going to subtract all the ways with no, or again, 4 or fewer. And so what I would do is I'd actually start by saying, okay, I've got 20 people trying out for the team. I'm going to pick 12. So this is all the different ways of forming the team right there. That's kind of from part A, no restrictions. Then what I'm going to do is I'm going to subtract all the ways to do 4 or fewer. So I would say, okay, I'm going to do a situation where I go 8, choose 4, times 12, choose 8. Okay, so this is with 4 grade 10s and 8 grade 9s. And this clearly isn't that doesn't satisfy the condition. So I figure out what that number is and I take it away. And then I rinse and repeat, and I can say 8, choose 3, times 12, choose 9. Again, same thing. Then I can do 8, choose 2, times 12, choose 10. Rinse and repeat. Because then I'm doing it. I've got to zoom all the way out here because it's a little bit longer. Minus 8, choose 1, times 12, choose 11. And then minus 8, choose 0, times 12, choose 12. And by the way, there's only one way to do this. One way. So this is actually just minusing 1 at the end, interestingly enough. Anyway, so that's how we do that. And we've already done algebraic problems already. Like, there isn't anything new with any of these. So I'm not going to bother making another video about this, but I will see you guys in the next one.